Audio Jungle. Audio Jungle.
So this is nothing but visualization of the flow. Visualization of the flow, right? In the visualization of the flow, basically we'll talk about the types of pattern. I told you there is the technique also, okay? That is also the part of the syllabus in visualization. So we are not talking technique, we are talking about the types of pattern here. Types of pattern. And what are the types of patterns here? So the types of pattern is nothing but basically the first one is very important, which is nothing but streamline. Okay, the first one is nothing but streamline, or we'll start from the timeline first. Timeline, because that will be the sequence. Timeline. Then second pattern we have here, path line. The second pattern is nothing but path line. Okay, then we'll talk about the third pattern, which is nothing but streak line. And the last one, which is very important and many times asked in exam also, that is streamline. That is streamline. So as of now in your examination, basically they have asked about the path line and streamline, and we have to write the equation also. Equation here, what is the equation of path line, that also very important. And here also for the streamline, what is the equation of a streamline? Based on this multiple time question in GATE they had asked. If I say question, then don't think it is only for GATE Aerospace. I always used to tell, whatever one day exam you are going to write, it is PSC exam, maybe ISRO or any DGCA exam you are going to write, FCAT you are going to write, okay, any examination you are going to write which is related to aeronautical or which is related to aerospace, so that will be important in that perspectives always. Number one. Number two, like everybody now they are filling the form for the GATE. So I always used to tell, uh, you have to choose, being aeronautical engineer, second paper you have to choose GATE XC. Don't choose GATE mechanical or civil or any subject, because in XC GATE you have thermo, fluid and strength of material. Three subjects are there. Any two subjects you have to choose, which is your related to your syllabus. Why I'm saying don't go for mechanical and all, because so much competitions are there, so we'll not able to prepare that level, because our concentrate is only aerospace. Exigate means thermo and fluid. So whatever the basic idea you have, basic knowledge you have, based on that you have to write the second paper. Okay, so I'm just remembering the GATE XC also. So based on that, I'm also giving the question or the solution, whatever I'm providing here, it is also related to GATE XC. Like if you talk about fluid mechanics, so in that way also this will be very important. Okay, now coming to this next, the explanation of timeline. Okay, so as the word here it is given, timeline. So a timeline is a basically set of fluid particles. Okay, if I say fluid particles, it doesn't mean only water, it will be both. Fluid means gas and definitely liquid. So we are talking about the water particles or it is about air particles. Okay, so a timeline is a set of air particles or fluid particles that form a line, at a given instant. Instant means it's a time. So for any given instant, maybe for 1 second, for 2 seconds, for 3 seconds. So how to draw the pattern? We have to take at any instant, we have to check the fluid particles. Okay, and it is marked the same instant of a time. So whatever the observation we will get, that observation basically it will provide the information of the flow field. It will provide the information about the flow field. So basically timeline, in In short, I will write here. So timeline, basically, timeline, if you draw the pattern of the timeline, so timeline pattern is somewhat like this you will get, okay? It's nothing but you can say this is suppose flow pattern. This is the flow pattern, something like this. This is the flow, okay? We have to make one channel like this. Now at time, different time we have to draw. Maybe the first pattern we are going to draw for the time period t is equal to t1. Then again we can draw t is equal to t2. Then similarly we can draw t is equal to t3. So for instant of time, means particular that time period, time period, suppose we are talking about at t is equal to t1. So at this time period we have to check the flow particles and it will follow the pattern something like this. See, so for t is equal to t1, whatever the fluid particles, it will follow the pattern something like this. Similarly, other flow particles, like at any time t is equal to t2, this is the other flow particles. Similarly here also. So means the point is, what is the point you got? The simple point, for different time zone, different orientation of the particles will be there. Okay, different orientation of the particle will be there, and it will be the fluid particles. Okay, and it will form a line for particular given time. Like suppose 100 fluid particles are there, so all the 100 fluid particles, suppose it is forming a line something like this. Okay, these are the 100 particles, and for t is equal to t1 we got this is the particles. Here it is available, and it is basically observing, it is observing the flow basically. Okay, it is observing the flow. That means it is giving the information of the flow field. Okay, so this is all about the timeline. So timeline is basically, timeline is a set of fluid particle, is a set of fluid particles that form a line at a given instant, form a line at a given instant. Instant means we are talking about the time. Given instant t is equal to t1. So at particular t is equal to t1 time period, maybe it is 1 second or 2 second or 3 second. So whatever the fluid particles they are making line, that is called a timeline. Means particular this time period, these are the fluid particles, so they are making one line. So that will be called as a timeline. What is the work of it is what is the work of the timeline? So basically this line, okay, these lines provide the information, okay, of the flow field, okay. So this is all about the time. And always remember these line, because this is the one line, this is the another line 2, okay, line 1, line 2, and this line 3. So one line, which is one timeline, that timeline will be marked at a same instant of time. If I say this line 1, so this will be marked for a same time period, means if t is equal to 2 seconds, so at the 2 second, whatever the fluid particles are making this line, this will be called timeline. The second one, this will be maybe for next 2 seconds, that becomes 4 seconds. This is the first 2 seconds, this line will be formed, this is the one timeline. Again after 2 seconds, maybe it becomes 4 seconds, t2 is now 4 seconds. So all the fluid particles, those who are making the lines, okay, those are the making lines, that all will be with the same time period, means it is all at 4 second time period. Similarly, the next line 3, this is also the next time period, which is suppose 6 seconds. So all are aligned with this, basically these particles are making one line. So all particles are existing at the same time period, it becomes 6. Okay, so this is for 2 seconds, this is for 4 seconds, this is for 6 seconds. So all particles are making line at 6 seconds, all particles are making line at 4 seconds, all particles are making at time 2 seconds. So this is called timeline basically, and basically this will be used to provide the information of the flow field. Okay, these are providing the information of the flow field. This is the work of the basically timeline. Okay, information of the flow field, number one. Number two, we'll talk about the second one, which is nothing but path line. This is also very important, path line. Okay, so what is the mean of the path line, and how will be the pattern of the path line? So simple path line, if you want to understand simply the path line, you take any fluid particle, suppose this is the source of the fluid particles here. Okay, this is the source of the fluid particles. Here fluid particles are ejecting. So take any fluid particle, suppose this is the one fluid particles we are taking. So these fluid particles, basically it is free in space to move anywhere. So in which direction or anywhere it is moving. Okay, so you have to take that fluid particles and trace the path, like in which direction it is moving, you trace the path. So whatever the path traced by the one single particle is called as a path line. That's the reason it is called path, because it is tracing the path. Simple, it is tracing the path. So this will be called as a, so basically this is what source and this is what particle. This is what particle. So this particle is what basically tracing the path. So that maybe direction, maybe anywhere it can go. So wherever it is going, you have to trace the path, and whatever the path is what created by that particles called the path line. Simple idea only. So if you want to write the single line definition of it, so because in examination they are also giving the statement, two line statement, and they will say like, okay, this is streamline, streak line, path line, or timeline. So simple here, if you check near 3-4 years back question paper, so theoretical based question they are asking. Okay, so we have to prepare for that also, like theoretically if they are asking questions, so how to approach that. So path line basically single particle we have to take, and we have to follow the path. We have to follow the path, we have to check the trajectory, we have check the traced path. That path will be nothing but a path line. Okay, so a path, simple definition, a path traced by fluid particle, called, simple definition, called path line, So always remember the path line. This is the number one point. Number two, what is the important? Second, the path line, always remember, the path line always follow the Lagrangian concept. Always follow the Lagrangian concept. Okay, follow Lagrangian approach, I have to say. So what is the Lagrangian approach? Very important. So basically two types of approach we have to study the fluid particles. What is that? First one is the Lagrangian approach. Second one is Eulerian approach. Lagrangian and Eulerian approach. So we have to write here, see, approach. This is also very important. Approach to study fluid particles. Okay, so what are that two approach? You have to listen this two, it's very important. Nothing but Lagrangian approach, and Eulerian approach. Okay, how to identify which one is the Lagrangian approach and which one is the Eulerian approach? The best example I will give, suppose during the bike checking. Okay, during the bike checking, one way the policeman will stay at some particular point, and policeman is what simply standing at some points, and the all bikers or vehicles are going in front of that policeman. Okay, so he is checking there. That is the one approach. Second approach, the and he's checking all the documents, driver license or insurance, whatever it is called, like pollution and all documents is checking. Number one. Number two, the policeman is what sitting the with the biker. Bike is what moving, and he's sitting behind the biker, and he's asking, okay, show your documents. In the same way, you have to think about the Lagrangian approach and Eulerian approach. So what approach I told you, like policeman is what sitting behind the biker and asking the documents, called Lagrangian approach. And Eulerian approach means the policeman is what is standing at one point, and all the bikers and vehicles are going there, and he's asking, stop bike, stop car, and show your documents. That is Eulerian approach. Meaning is, for the Lagrangian approach, we have to move. We have to move with the fluid particles. To study fluid particle, we have to move. Okay, we have to move with particles, with fluid particles. Okay, to study flow field, or to study about fluid particles. So we have to move with the fluid particles. That is called Lagrangian approach. What is the Eulerian approach? So for the Eulerian approach, we have to fix point. We have to stand. We have to fixed point somewhere, and all particles will move through the points. So all particles are moving through the point. It's simple. For this, if you want to study about any fluid particles, so the fluid particle started from here, okay, and this fluid particle is what moving like this. And similarly here, this fluid particle is what simply moving like this. This fluid particle is what moving like this. Okay, so this will be a Eulerian approach when the observer is what fixed somewhere, and observer is what is standing here. Observer is what is standing here, and all the particles are moving in through this point. And observer is what observing the fluid particles, observing the fluid field. Okay, this is called Eulerian approach. This is Eulerian approach. Eulerian approach. What about this? Here the observer who's sitting on the fluid particles, and with the fluid particle, suppose now the fluid particle is what reach at this point. So here also, because observer is what moving with the fluid particles, so observer is what again reach to this. When he's moving with the fluid particles, right? He's moving with the fluid particles. So that is called Lagrangian approach. It's very important to identify both approach. Okay, so this is called Lagrangian approach. All right, Lagrangian approach. All right, these two approach. Hope this one is clear. So for now you can self-identify what is the path line. I told you path line, a path traced by the fluid particles, called path line. So means with the particles, observer is what move. Okay, if you want to check the what is the path line, so obviously with the particles you also have to move with the with the particle only, then you will able to study the particles. So and at that same time, if you check the particle, what is the path is what tracing up, down, straight, or circular, or whatever the motion. If you want to check the if you want to study about the particles, then you have to move with the particles, and whatever the path traced by that particle, that will be called as a path line. So basically this path line always follow the Lagrangian approach. Always follow the Lagrangian approach. Now coming to the next what we have here? After path line, we have a streak line. We have a streak line. So in streak line, this is very special streak line. So third one is nothing but streak line. Streak line. Okay. So how to identify the streak line? So basically, a streak line in this case, all particles. Okay, in this case, whatever the all particles are flowing, and it will pass through a common points. Okay, it will cross through the common point. Simple example I will give, just like a chimney. Okay, suppose this is the chimney here. This is the chimney. Okay, this is the chimney. Now if you see, you can check. Now these three different points we have. These three different points we have. This is the one fixed point, this is the another fixed point, and this is the next another fixed point. So with the first fixed point, suppose all the fluid particles, okay, because multiple fluid particles we have, so these fluid particles are passing through this single fixed point. Okay, so this is the one point, this is the another point, this is the next another points. But what is the common thing for these all points? They are passing through the one fixed point. They are passing through the same fixed point. Okay, this is the fixed point. Similarly, if you talk about this, so here also fluid will pass something like this, and multiple particles are there. So this is the one particle, this is the another particle, this is the another, this is the next another. So what is the common for this second? These are the passing with the second fixed point. This is the first fixed point, and this is the second fixed point, and this is what? Third fixed point. So similarly here also. Okay, similarly here also. So all fluid particles are passing through the same fixed point, which is nothing but point number 3. If I ask what is the common for streak line, okay, so whatever these fixed point we have, 1 2 3, from this 1 2 3, whatever the particles are passing, okay, whatever the particles are passing, if you check the instantaneous picture, so that particle will be observed like this. If you focus, if you torch on the particles, so particles will be arranged in this way. If you all particles, if you make if you meet all particles with the lines, so this line will be called as a streak line. Okay, this points will be called as a streak line. Now if you check what is the approach here you are getting, approach is very simple. Here we have the point, fix the point 1 2 3, and from the fixed point 1 2 3, all the particles are passing. All the particles are passing. So this is the Eulerian approach, or Euler's approach, or Eulerian approach you can say, because here all the particles are passing through one fixed point. Okay, so and if you make a torch of this, then all particles will be passing through one fixed point, and after passing through the fixed point, if you meet all the particles with a dotted line, then it will be one line, which is nothing but streak line. So this is one streak line, this is the one streak line, this is the another streak line. Obviously this streak line is 3, and this streak line is first, in between another one more streak line. So all three streaks line, all three are the streak lines, but it is not common. Why? Because they are passing through the different fixed points. So but properties wise it is a streak line, but they are not same, they are not common, because it is not passing through the all same points, it is not passing through. Okay, that is the point here. So if you say about the streak line, so streak line is basically an instantaneous picture of the particle which is passing through a fixed point. All particle which is passing through one fixed point, if you make a torch on that, then you will get the particles are moving like so. Other one more, you can take the example like we have seen the dye, or smokes, we have seen cigarettes smokes you can say, or it's the chimney smokes we can say. So the particles are passing through a one fixed point, and all particle you have to make by one common line. You have to draw a common line. Suppose this is the spray. You are ejecting this spray. So these spray particles will, these are the spray particles, okay? These are the spray particles, but it is passing through a one fixed point. One fixed point we have, and from the same fixed point, all the particles are ejecting here like this. If you meet all the particles with one single line, so this line is called a streak line. This line is called streak line. Okay, this line is called streak line. Now coming to the definition of the streak line, so it's very simple. A streak line, we can define a streak line. A streak line consists of all particles in a flow that has previously passed through a common point, or through a fixed point. Okay, through a fixed point. So this is the first point what you got. Second point, it is also defined, it's a instantaneous picture. Instantaneous pictures of particles passing through a fixed point. And what is the important point? What is the approach here? The point is third one. It follow the Eulerian approach. Okay. Follow Eulerian approach. Always remember, by Eulerian approach, I told you Eulerian approach in the sense you have to fix at one point, or observer will be fixed at one point, and all the particles are passing. Okay, that is the Eulerian approach. So this is called a streak line. Okay, streak line. Basically, they are obtaining, how to obtain this streak line. I told you, take instantaneous photographs or take instantaneous picture of selected particles that have passed through a given location in a flow field. So if you want to observe a streak line, you can observe in that way. You have to take the instantaneous picture. Suppose this is what simple, this is what cigarette. Okay, this is what cigarette, and cigarette is what burning. So obviously particles will be coming. If check, all the smoke particles will be going like this. All the smoke particles will be going like this. If you want to check where is the streak line, so take the instantaneous picture of all the smoke particles, and you have to connect the points, connect the particles, because all the particles will be different location, and you have to observe there the how many particles are passing with the same fixed point. So all the points, all the particles you have to meet with single line, so you will get the streak line. This is the way to get a streak line. So it's a nothing but it's a instantaneous picture. If you take instantaneous picture of all the particles and draw the lines between the among all the particles, then you will get one line called a streak line. Simple. Now coming to the most important, which is called streamline, which is very important. Okay, streamline. So the streamline, basically it is also defined, see, like if any particles is following any path. Okay, if any particles who is following the path, so about the, and in this way you can understand the difference between path line and streamline also. So if you draw the tangent to the line, if you draw the tangent to the line, so that tangent will always give the direction of the flow at every points, at every points in a flow field. Simple, I'll show you. Suppose now this is the path line, okay? Because this particle, this is the one particle here, and this particle is what tracing a one path. This particle is what tracing one path. So this particle is what tracing the path here. So now this becomes path line. But now for this particular line, if you draw the tangent, so how to define the streamline? So this will be a streamline if you draw the tangent to this line, and this tangent will give the direction of the flow field. Direction of the flow field. Okay. So these are the lines drawn in a flow field so that at a given instant they are tangent to the direction of flow at every points in a flow field. Okay. So basically in single line, if you define what is the streamline, so I must say streamline. Again, I will elaborate, don't worry. So basically streamline are tangent to the velocity vector at every point in the flow field, okay. Number one. Number two, the very special this is the point one. The streamline basically it's a tangent to the velocity vector at every point in the flow field. Okay. Now what is the important point for this? The streamline cannot intersect, they cannot cross to each other. Okay. And they cannot cross to each other, that is one thing, because I will give the properties also, because properties for the streamlines are 4-5 properties are very important. So the first point I have written the definition, which is nothing but streamline are tangent to the velocity vector at every point in the flow field. Okay, in the flow field. Second point, the streamline cannot intersect to each other. Okay. So this is the definition of the streamline. Okay. Now coming to the streamline, see another one more definition I will give. Like if there is the streamline, suppose now this is the streamline. If this is the streamline, so it will form a virtual solid surface. Now it is form a virtual solid surface, means the flow cannot cross the streamline, because this is the one property, the streamline cannot intersect to each other. I will tell you why it cannot intersect, but at the same time you have to also remember the flow cannot cross the streamline. So this is also very important. The flow cannot cross streamline. Actually it will form a virtual solid surface. That means the flow is what not crossing to this surface, means in this direction the flow cannot cross. Here cannot cross, like this the flow cannot cross. Okay, always remember. So that is very important. Again you will understand why it is. See, so the explanation for this, why because it comes from the second point, streamline cannot intersect. Because see, if two streamline we have, this is the one streamline and this is the another streamline. So as I told you, the streamline is nothing but basically it's a imaginary line. And obviously if draw a tangent to the streamline, then you will get velocity vector. Okay, you will get the velocity vector. So suppose this is the streamline, and we are drawing the tangent to at this point. At this point, I am saying if you are drawing tangent to this streamline, so this will be the one velocity vector, which is nothing but v1, we can say, and tangent to this velocity vector will have a tangent to this streamline will get the velocity vector here. So v1 and v2. So at the same point, two velocity vector we cannot get, or two direction of the flow we cannot get. For that reason, we are saying it cannot cross to each other. Okay, so streamline are imaginary curves drawn through a fluid to indicate the direction of motion in various sections of the flow field, and a tangent at any point on the curve represents the instantaneous direction of the velocity. Suppose if I say, if it is a streamline, or if we say this is the curve 1, this is the curve 1, and this is what curve 2. So for curve 1 and curve 2, if I say this is the streamline, so if you draw the tangent, then you will get velocity vector, and velocity vector you are getting, it means velocity is the vector quantity, means it will have a direction. So at single point, how two direction is what possible? It is possible at single point, two direction of the flow is possible. No, it is not possible. So two direction of the flow is not possible at single point. Hence, we can say the streamline cannot cross to each other. Always remember, okay? Always remember, that is the mean of it. That is the mean of it. That's the reason we are saying the flow cannot cross the streamline. The flow cannot cross the streamline, because flow direction itself is nothing but a streamline basically. That's the reason it is said nicely. It is said nicely. I have written the definition also. Here in previously. This one, first one, the streamline are tangent to the velocity vector at every point in the flow field. Okay. So always remember, if you are having multiple streamlines, so it will make a stream tube also, and that we are using for the analysis of the flow. If you want, like Bernoulli equation, discharge, continuity equation. So on the computer software, how you will check the how you will check the validity of discharge equation, Q is equal to AB, A1, V1 is equal to A2, V2. How you will check it? What I'm saying, we have a continuity equation. Discharge is nothing but area into velocity, we know that, and that is constant, we know that. So if want to check A1, V1 is equal to A2, V2, that is, and this is the continuity equation for incompressible fluid, right? If we want to check the validity of equation, this is right or wrong. So in software, how you will check? Because in computer software, the physical channel you will not get, that duct you will not get. So how to make the passage? How to make the channel where the flow is possible? So through the software, you have to create the channel, you have to create the passage, and that passage is nothing but basically stream tube. To validize this continuity equation or Bernoulli equation, to check the validity, we have to through the software we have to create a stream tube, and stream tube is nothing but it's a bundle of streamline. It's a bundle of streamline. See, it's a bundle of streamline like this. This is the bundle of streamline here. Now if you all streamline, if you make check this, something like this. So this is like a tube, it becomes a tube like this, and you know the property, perpendicular to this streamline the flow is not possible. Perpendicular to the flow is not possible. Why? Because if this is the curve, so what is the streamline? If you check, if this curve is itself a streamline, it means tangent to this curve will have a velocity vector. So the velocity vector will get just parallel to the curve. We are not getting perpendicular. So what is the perpendicular to the streamline? Velocity is what? 0. There is no perpendicular. So basically, normal component of the velocity over the streamline will be 0. Only tangential component will have that value. Because tangent is what? Tangent means it only tangential value will have. There is no normal value. There is no perpendicular value. If there is no perpendicular velocity over the streamline, so obviously over the stream tube. Suppose this is the surface of the stream tube. This is the surface of the stream tube. So perpendicular, there is no velocity actually. If there is no velocity, means theoretically we can say the flow is what not leaking from the YouTube, from the stream tube. Sorry, from the stream tube, the flow is what not going to be leakage, because there is no perpendicular flow from the stream tube. There is no flow leakage from the streamlines, because they are not crossing the streamline actually. They are not going to cross the streamline because there is no perpendicular on the streamline. Why I am giving so much time for this streamline? Because this is very, very important. And the concept behind the streamline, it is very necessary to understand. Okay. So basically, anywhere when a bundle of streamline are considered in a flow field, it constitutes a stream tube. I need to write here, when a bundle, when bundles of streamlines are considered in a flow field, it constitutes a stream tube. Constitute a stream tube. Okay. So always remember, and when this tube is possible, what is the mean of it? Because everywhere that streamlines are parallel to each other. If I draw the streamline, so streamline, if I'm drawing in curve also, so this curve will maintain the equidistance. It will be equidistance. Okay. That means it is parallel. Okay. If it is parallel, means they are not going to cross to each other. They are not going to cross to each other. That's the mean of it. Okay. So the streamlines are everywhere parallel to the local velocity. Fluid cannot cross the streamline. I'm saying again and again, because this is very important property basically. Okay. And so these few points I need to write here for the streamline properties. So this is the equidistance, number one. Number two, here also you can write the fluid cannot cross streamline, and you also write first point is streamline better. Streamlines are, and don't worry, in my notes all the theory part you will get. Okay. Everywhere parallel to the local velocity. Number two, this is very important property, fluid cannot cross a streamlines. Okay. Third point, a stream tube. You know, now you understood what is the stream tube. So if streamlines, if make a bundles of streamlines are considered a stream tube. Okay. So in a stream tube remain there and cannot cross the boundary, at stream tube. At stream tube. So the boundary of stream tube, the flow will not cross. Okay, so remains same, means whatever the flow is what in, flow in, and we have here flow out. There is no leakage, nothing. So what is the application of a stream tube? You can say for the validation of continuity equation, for the validation of Bernoulli equations, we have to use a stream tube, because it's just like a channel which behave like a solid channel. There is no leakage and all, because stream tube is nothing but made by the bundle of streamlines, and we know the property of streamlines, there is no perpendicular velocity to the streamlines. only tangential velocity component will have. Only tangential velocity component will have. If I say simple, another property also you can understand in this way. If I say my flow is possible, my flow is what possible from left to right. This is left, this is what right. Huh? If I say flow is what possible left to right, like this, it means flow is possible left to right. So what is this left to right? This always we have to draw this pattern, right? We have to draw this pattern. But what is this? This is path line, timeline, streamline, straight line. So this is what streamline, because streamline clearly in three different definition I have given. Streamline is basically it's a direction of the flow. Clearly I have mentioned. Clearly I have mentioned it's a direction of the flow. Okay, it's the velocity vector. So if I say the flow is what horizontal velocity we have, if I say this is the horizontal velocity, so means the velocity vector in this direction means in this direction the flow field we have. So both way we can say the flow is what from left to right. So it means if we are showing the pattern of the flow field left to right, right to left, bottom to top or top to bottom or inclined flow, whatever we have, like this inclined flow also, suppose we have this inclined flow. So if I say this is what timeline, path line, streak line or streamline, so you have to say streamline, because streamline itself a direction of the flow. Streamline is nothing but itself a direction of the flow. If you draw the any curve, I told you many times, if you have draw one curve, if you want to draw the tangent on this curve, so that tangent on this curve, this tangent on this curve, so this will be the velocity vector. This will be the velocity vector. Tangent on the curve will be nothing but a velocity vector. Okay, so whatever the direction of the flow we have, that is nothing but streamline. So we can say we have the direction. The streamline have eyes. They can, I mean, they are not blind. They can see the direction. If I say left to right, so only streamline have eyes. They can see from left to right we have to move. So whatever the pattern everywhere you are showing, that flow pattern you are showing, it is only a streamline. Okay, it is only streamline. Path line don't have any particular, you cannot say it's the direction of the flow. No, that is the trajectory, that is the path traced by the particles. But if I say the direction of the flow is from left to right, it means it's a streamline. Okay, now the point is, if you want to draw the path line, then how you will draw? So obviously first you draw the streamline, then based on that streamline you can draw the path line. That is the one thing. But path line do not have any direction, streamline will have a direction. Okay, that you always remember. So the tangent at any point on curve represents the instantaneous direction of the velocity of the fluid particle at that point. It means if this is what curve, this is the curve, so this will be the velocity vector, this will be the velocity vector. So if you draw the multiple streamlines, so it will constitute a flow field. It will constitute a flow field. Okay, that is the whole explanation about the streamline. But still anybody is what interested to ask any a particular somewhere doubt in streamline, you can ask to me. There is no problem. I'll explain it. Okay. So up to here it is clear to everybody. Right. Now we have to talk about the equation of the streamline. We have to talk about the equation of streamline. So that equation of streamline, if you want to draw equation of streamline, equation of streamline. So if I say simple, if I say suppose this is the flow pattern like this, this is the flow pattern. Okay, so if I take one particular fluid elements here, okay, for this particular fluid elements, definitely position vector we will have, and we can say the tangential velocity vector is v here. So we can make two components, one is horizontal u and another is vertical v, because we know the coordinate system. This is x and this is y. In x direction, what is the displacement? It is dx displacement, but velocity is what? Nothing but u. And similarly in y direction, what is the velocity? V. So the total velocity, suppose v vector we have, so we can write v vector is equal to what? We can write u I plus vj. This is the way to write, right? So if we are interested to write the equation of streamline, so it's very clear. It's very clear. This particle, we can write the position vector of this particle. So the position vector or point, because this is now 1 point. So here, what will the position vector? It is dr vector. What is the mean of dr vector? Because position vector is nothing but r is equal to xi plus yj. For 2D I am saying. So what is the dr vector? It is nothing but dxi and dyj. For the small segment, we can say. So two things we have. If we are writing the cross product of two vector, then what is the mean of it? Okay, a cross b. What is the mean of this? And a dot b. Two vector we have, a dot b and a cross b. What is the mean of? So whatever the result here you will get, that will be normal to the surface. Okay, normal to the surface, normal to the surface. Whatever the result will get, a cross b vector. Okay, you may see, you may remember the cross product. It is a b n cap sin theta, right? So n cap is what? Normal to the surface. So whatever the result we'll have here, whatever the result we have here, it will be normal to the surface. So if we have, if you check, we have the elements. What is the element? Suppose this element we have here, and this is the position vector dr, and for this we have drawn the velocity vector v. So if I write the velocity vector cross product to dr, then what is the result? Means normal to the surface, means normal to this streamline. So I just now I have explained, normal to the streamline there is no flow. See, normal to the streamline, normal to the streamline there is no flow. So that cross product will be 0. Based on this, you can write the equation of streamline. So this is nothing but 0. Simple. Simple. Okay. So now it's a very unique equation of a streamline. Based on this concept, you can write simply what you will do. You just write the vector format. So what you will get? Simple velocity vector. If you check, v is equal to, we can write ui plus vj, and if we are interested for 3D, then we can write wk. So what is the u v w? See, simple. It is x, y and z. In z direction velocity is nothing but w, in x direction velocity is nothing but u, in y direction velocity is nothing but v. And similarly, if you are interested to write the position vector for infinitesimal element, then dr is nothing but dxi, okay, dxi plus dyj plus dzk. So equation of streamline is nothing but v vector into dr is equal to 0. So this is now your homework. You have to further, you just write v vector cross dr vector and make it equal to 0, and then find the equation. Final result I want in next class. So you do it. Still further explanation we have for the streamline, we'll do that, and we'll solve the exam problem also in next class. All right? Okay.